All right, hello, data scientist peers. It's good to be presenting to you today about the methodology for the creation of my report that was exploring meat consumption around the world. So first of all, my data source was my data came from two sources. One was the United Nations Development Program Human Development Reports, and one was the Organization for Economic Cooperation and Development meat consumption data. Uh, like I said, open data CSV format. I uploaded these CSV files to Watson Studio where I could access them as Spark data frames. Okay, so data integration. I used Apache Spark from within Jupyter Notebooks. It is easy to load CSV files as Spark data frames, and also it is easy to access and manipulate data in a Spark data frame by using SQL queries. Data repository. I use IBM Object Store. My dataset was only a few CSV files, so it was suitable to store them in Object Store. Object Store also integrates with Watson Studio, so it's easy to access my files. Okay, so data preprocessing for the United Nations data. Preprocessing was fairly simple, trimming white space in columns, removing blank columns. The OECD data was a little bit trickier. I had to remove future projected. The data set included data that was not actual data but projections data. So anything with a year above 2018 I removed. I only wanted measurements that were in kilograms per person of meat consumption. I didn't want the data that was in how much thousands of tons the whole country consumes. I got rid of all that aggregate data. So the data was split up. Each meat type had its own row, but for convenience, I wanted every meat to be in the same row for a given year for a given country. So I had to do that. Also, for some countries, Norway and Switzerland, I believe, didn't have data in kilogram per person. So I had to just take the data that was for the whole country, then look up the population data for those two countries and calculate kilograms per person manually. The final step was to join the data. So I joined that United Nations data with the OECD meat consumption data on country and year. The slight issue was that the United Nations data had country names and the OECD data had just abbreviations. So I figured out the format was the international format, ISO Alpha 3 abbreviations. So the UN actually has a CSV file, which is a key taking country names to abbreviations. So essentially it was a join on three separate data frames that allowed me to combine the UN and the meat data. Okay, feature engineering. So I noticed early in my explorations that Human Development Index rank was highly correlated with life expectancy. So, I had to drop that column when I was predicting life expectancy. Otherwise, it would be too simple to predict. Sometimes I use individual meat types. The meat types were pig, sheep, beef, poultry. Sometimes I add it up. I just use meat total as a feature. For my main model, actually, my classification model, I used the proportion of each meat was of total meat consumption as features rather than the raw meat consumption amount. I also used PCA, my dimension reduction didn't really work too well. Min-max normalization, most of the time my models worked fine without normalization, didn't need it. In the case of proportional data, it already is normalized, so that's another thing. Okay, discovery and exploration. I use Jupyter Notebooks for creating visualizations and calculating metrics. I just created simple, charge scatter plots, primarily with matplotlib and Python. Didn't have a lot of variables, so mostly, two-dimensional charts are okay. For calculating metrics, I used MLlib, the Apache Spark, in Apache Spark and Python. The MLlib statistics class. You could easily calculate correlations between RDDs. Okay, actionable insights. I used Python, Apache Script, and Spark ML. I already had my data as a Spark data frame, so my pre-processing was done in Spark. Spark ML is an easy to use pipeline format, and it also out of the box supports many machine learning models. I created a linear regression model and a random forest classifier model. So my first model was a linear regression model, looking at how well all my other data points minus HDI rank could predict life expectancy. And I used regression in this case because life expectancy has, a continuous range, starting in the 50s to the 80s. And then for my second task, I used the random forest classifier to predict what geographic region the country was in based on the meat consumption patterns of that country. So first I tried standard decision trees. It was giving me, okay scores of like 70 or 60% accuracy. Then once I tried random forest, it got me up to like the 80s or even the 90s in accuracy and other metrics. Okay, model evaluation. So to evaluate my linear regression, I used root mean squared error because that basically tells you what the average error is for each prediction, the error between your prediction and the actual data point. So considering I had this pretty high RMSE of about 4.7, which for my data seemed pretty high, I knew the regression model was not exactly working that well. And I used that inside of my report. I used F1 score to evaluate my random forest classifier. So as you know, F1 score is the harmonic mean of precision and recall. So since I had an F1 score of 0.9, that means that my classifier was doing really well both on precision and recall, meaning it was getting countries in the right category, picking the right region for countries at a very high rate. Okay, application and data product. So I conveyed my findings to the Jupyter Notebook, exported to PDF. Jupyter Notebook allowed me to show a step-by-step procedure of how I got my results and also allowed me to include a lot of charts. And finally, I created a web application that interacted with my random forest classifier. So this allowed anyone to kind of using their own data from their own personal experience, interact with that random forest classifier, and see how it works for themselves. All right, thank you, Piers, for watching, and I hope you learned something from this presentation. Thanks.